Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt, because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called 7 Ridiculous Facts About Chaos, and it's by Randall and Michael Lefkowitz. And here are the rules. We have chaos construction rule set, where we need to divide the grid into regions of 7 cells and place the digits 1 through 7 once each in every row, column, and region. Excuse me. And the regions have to be orthogonally connected. Which means that you can go from any cell in the region to any other cell in the region just by going through edges, all while staying within the region. I don't know why I'm coughing. This is just suddenly I don't know. But this is a valid region here because, again, to get it from any cell in the region to any other cell in the region, you can just go by going through edges, all while staying within the region. This is not valid, though, because to get from this cell to any cell in the region, you either have to go outside the region or you go through a corner, not an edge, which is not allowed. So that's how chaos construction works. We also have X-sum circles, where a digit in a circle counts how many cells of its region it sees in the row and column combined, including itself. And region borders obstruct vision. The number in the attached rectangle, if given, is the sum of those digits. Interesting. Region borders obstruct vision. So a digit in the circle counts how many cells of its region it sees in the row and column. So this would be 2 if that's the case, right? Because it only sees these cells. Even if like it went here, it would still see 2 because it would not see that cell because region borders obstruct vision. So it only sees these 2, does not see that one because this is a region border here. And the number in the attached rectangle is the sum of those digits. Well, obviously this doesn't work because 2 and whatever digits here can never add up to 28. But the number of the digits that the circle sees must add up to 28 if that's the case. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, for these to be 28, it has to be 7 cells that it sees, right? 1, 2, 3, 4, 5, 6, 7. 1 through 5 adds up to 15. 6 and 7 add up to 13, which is exactly 28. So this must see all cells of its region, and this circle must see all cells of its region. To get to 23, you see either 6 cells or 5 cells. You cannot see 4 cells because the max for 4 cells from 1 through 7 would be 4, 5, 6, 7, which is 22. So this has to be see 5 or 6 cells. This will mark as pink. This, I guess, will mark as green. To see 10 adding up in its region would have to be either 4, 2, or... no, can it be 2? No, it can't be 2 because that would have to be 2 and 8 to do that. So this is 3 or 4 that it sees for 10. To add up to 22, I think it has to be at least 4. And it could be 4, 5, or 6. Can it be 6? It cannot be 6. If it sees 6 exactly, that would have to be you missing one digit that it doesn't see. And you cannot, and that digit could not be the 6, which means that you can't ever sum up to 22, right? 28 minus any non-single digit, which is not 6, can never add up to 22. So this is 4 or 5 here. So this cannot be green. This is some other region here. So it could be all 7. If it goes, okay, so this cannot be all 7 here. Because this, if this would be then part of the same region, and then it doesn't add up to 23. It would see all 7. So this must go that way because of that. And so similarly, it can't go all 7 this way because you have the same problem here. This doesn't work to be part of the same region because if it were, already 3 and 7 add up to 10, and then this is at least 1. So this has to go this way. And this therefore sees 6 cells. So these add up to 23, and it must be missing a 5. So this is 5, which makes this 1, 2, 3, 4 is the remaining digits, and the remaining digit in column 1 is a 5. So now we have, so let's do box borders. So that means this, oops, edge only. So this is a boundary. So this is, we're going to make this red. This 5 eliminates 5 here, so this is 4. That makes this not 4, so it's 3. And the 4 that must be part of its boundaries, it's either cannot be part include 3 because it has to add up to 22, and 4, 5, 6, 7 adds up to 22. We need a 5, so it cannot be all the 5s here, so this must go 5 here. So this is, we'll mark this as blue. It cannot go here, it has to go to here. This has to be 6 or 7. And this cannot be 7, because if it's 7 here, it can't see this cell here. So it must see 6 cells, which means this is 7. This is a boundary, because this can only see 4. So this is a boundary, so this must see 6. So it's 1, 2, 3, 4, 5, 6. So that's done as a boundary. That means the remaining digits in the region is 1, 2, 3. Remaining digits in row 7 are 1, 2, 3. This sees 3 cells. Interesting. So this cannot be 3. This can't be 3. And they add up to 10. So it's either 1, 3, 1, 6 or 3, 2, 5. Remaining digits in column 7 are 1, 2, 6, 7. This can't be 7, no 6, no 7. Because of the 7 and 6s in the region. Or sorry, in the rows. Can this go straight up and down? I think the answer to that is no. 1, 2, 3, 4, 5. So 5 plus 6 is 11. 12, 13, 14. Oh, wait, no, it could go all up and down. Interesting. Okay, this goes at most 3 this way. So then it cannot go here. It has to go here. So this is necessarily part of this region then. Right? Because it can go at most 3 that way. And so then it can't even go that 3 that way because it sees that cell. So then it has to go 2 that way. And then this is a border. So it's either 1, 6 as a pair, or this is 2 and 5. We don't know. It must go this way to continue. So that's 6, and then this is obviously a different region. So we'll make this dark. This must go either here or here. We're not sure which. This has to have access to a 7, and it cannot have access to a 7 going this way, so it must have access to a 7 going that way. So this is 7, so this is the full region here. That leaves the remaining digits in box in this region to be 1, 2, 4, 5, 6, right? So we're guaranteed a 4 and a 5 here. And then 4 is one of these. That means the remaining digits in column 6 have to be 1, 2, 3, or 6. Okay. 7's going to be one of these two. Okay, this cannot be 7. Where is the 7 in column 7? It has to be here. Okay. Where? Sevens have to appear in one of these cells here. And there's 2 7s here. This cannot be 5 because of 5 in the row. We have a 1, 2, 3 triplet here. That leaves just a 4, 5 pair in column 5. This can't be 5 because of 5 in the row. So that's 4, which makes that 5. 4 eliminates 4 here, so that's 3. It cannot be 3 digits this way. So it must be either... okay, so this cannot be part of pink, guaranteed. Can it be part of dark? 1, 2, 3, 4, 5, 6, 7, 8. No, so this has to be a separate one. So we're going to make this yellow. It has to go 1 this way, and it could be 2 this way, but we don't know. 7, it can only go 1, 2 here. I mean, it could go that way. Yeah. We don't know. This can't be 6 because of the 6 in the row. This must be, again, 1, 6, or 2, 5, adding up to 10. But we don't know which way it goes. Okay, this 3 eliminates 3 in the rest of the row. So this must be 1, 2, or 6. Interesting. Dark needs access to 4 and a 5. Well, if it tried to access... it cannot access 5, avoiding this 5. So this must be dark. Which means the dark must connect here. It could just be all of this. We don't know. Or it could potentially go somewhere like this. 1, 2, 3, 4, 5, 6, 7. The problem with this, though, okay, so it cannot do this because the problem is then this sees more than 3 cells, right? Because this can only be part of that if that's the case. What happens if it goes here? 1, 2, 3, 4, 5, 6, 7 at most. So that doesn't work either because then this would have to see 4 cells. So it going just here does not work. So it has to basically just be all of this. and this is all a region. So this is the 3, because there's no other place for the 3 in this region. This is a 6, so this cannot be 6 here. That means this can't be 3 here. The remaining digits in row 2 are 1, 2, 4, and 6. Okay, so this could be yellow this way. This digit is the same as that. Remaining digits in row 3 are 1, 2, 3, 4, 5. And this can't be 3 because of 3 in the column. This can't be 3. So this either sees 3 this way or 3 this way. I think this is always pink, right? If you see pink, it's either all 7 this way or it goes this direction. But it can only go twice this direction. Actually, can't even go twice this direction, right? If it tries to go twice this direction, oh, it could, I guess. You could have a yellow that way. It would have to be something like that. But that doesn't work. Hold up. So if you go twice this way, this must see all 7 cells on the line. So if it sees twice here, 3, 4, 5, 6, 7, or twice here, 3, 4, 5, 6, 7. So these are definitely pink no matter what. Can you do 2 here? So if you go 2 here, the problem with this is guaranteed to be pink that way, and the yellow has to be all here, but then this sees 4 cells. So it cannot be pink both that way. Therefore, there's only 1 at most here this way, possibly. And it could be 1, 2, 3, 4, 5, 6, and then one of these as the 7th. So these are guaranteed to be pink. So this is a boundary. We know actually all of these are boundaries because this cell must see all of the cells in this region. Remaining digits in row 4. 1 through 6. This can't be 5. This can't be 3 because of 5 and 3 in the column. Yellow must get access to one of these 7s here. And it can't. 1, 2, 3, 4, 5, 6. I think this has to be yellow here. Even if it's this way and then going here. Right. So if it's only this 1, 2, 3, it has to go here. 1, and that'd be 1, 2, 3, 4, 5, 6, 7. Even if it's 3 this way, it can't go any more here, so then these are yellow. 4, 5, 6, 7. So either way, this is 7, and this must be yellow. So this is yellow, all of these are yellow, and it's either here or here is yellow. Okay, so this is a 7, which eliminates 7 here. This must be 7 here then, because that's the only place for it in row 6 or column 3. So this is red. So this is either red or yellow, and this is yellow or pink. This is red or pink, This has to be red. You're guaranteed one of these is yellow, so this is a border, which means this is always red. This is always red. This could be red or pink. We don't know which. Okay, so 3 cannot be here because of 3 in the region. Where is the 3 in row 3? Cannot be here because of the 3 in the region. This is a 6. This sees that 3 there. This already has a 3 in a region. This has a 3 in a region, so this must be a 3 here, which means this cannot be 3. This is a 1-2 pair, which eliminates 1 and 2 in the rest of the row, so that's 3. This cannot be 5 because of the 5 in the column. This must then be 1, 2, 4, or 6. 3 has to be one of those two and one of those two. Remaining digits in row 5 are 1, 2, 4, 5, 6. Remaining digits here is 1, 2, cannot be 3, 4, 5, 6 also. We have a 1, 2, 1, 2 pair in column 4, which eliminates 1 and 2 in the rest of the column. So this is a 4, 5, 6 triplet here. Interesting. The red already has a 5, and so does the pink. And this is red or pink, so this cannot be 5 here. This cannot be 5. Where is the 5 then in column 3? It has to be here. And yellow needs access to a 5 because this is a 1, 2, 4, 6 quadruplet. So this must be yellow, which means this cannot be yellow here. It's pink. So this is done as a region. This is done as a region. Let's see. What else do we have? 4 is guaranteed to be one of these 3 digits because 4 cannot be here. This is 2. So this is 2, 5, and 3 adding up to 10, which eliminates 2 in the rest of the column. This can't be 2, that's 1, which makes this 2, which makes this 1, so this can't be 1. That's a 2, 6 pair, which eliminates 2, 6 in the rest of the region. So this is 1, which means this can't be 1 here. 1 cannot be here or here. Actually, no, it can't be here. 2 and 3 must add up with 5 to add up to 10, or 6 and 1 is here. So this cannot, this is 1, 1, 3, 6, or 2, 5, 3, 2. This is done. This cannot be 2 here. So this is a 1, 4, 6 triplet, which eliminates 1, 4, 6 in the rest of the column. So this has to be 2 here, which eliminates 2 here, no 2 here, no 2 here. This can't be 2. Red already has a 2, so this cannot be red, therefore it's pink, which means this can't be pink. So this must, so we have our boundaries, and this must be a 4, 6 pair here. 5 eliminates 5 here. Where is the 5 in column 4? It has to be here, which eliminates 5 here. So this is 1 and 6 adding up to 10 for this orange. That eliminates 1 here. So this is 2. This can't be 1 or 2. It's 4, which means this can't be 4. It's 1. 4 eliminates 4 here, so it's 6 and 4. This can't be 4 or 6, so it's 1, which makes that 4, which makes that 6, which makes that 4, which makes that 6. This can't be 4 or 5, so it's 2. This can't be 2 or 1, so it's 3. This can't be 1, 3, or 4, so it's 2, which makes this 3, which makes this 1. This can't be 1 or 6, so it's 4. 2 eliminates 2 here, so it's 6 and 2, and this must be a 5. And that's a solution. Yeah, I guess this is for chaos construction. It is easy. I don't know if I would consider it easy though. Maybe. I don't know. It's hard to say. Um, it was pretty quick, so it was on an easy level there in that sense, but I don't know. I'm not sure how to actually evaluate this for difficulty. It's definitely in between easy and challenging for me, but I'm not sure whether I would label it as easy or challenging. Hmm. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.